Hello.
So here we are with our new topic, and that is quadrilateral distinction using distance formula. So in this particular video, we will be using distance formula to distinguish different types of quadrilaterals. So let's start. For today, the learning objectives that we have are: first one, we'll try to distinguish different types of quadrilaterals on the basis of its sides and diagonals. Remember, we will be taking the sides as well as the diagonals. The next one is, we will apply distance formula to identify the type of quadrilateral. We will be using distance formula in order to find the length or the distance of the sides as well as the diagonals. And then we'll distinguish the type of quadrilateral on the basis of. In order to distinguish quadrilaterals using distance formula, we need to find 6 distances. Firstly, the distance of the 4 sides of the quadrilateral, and then the 2 diagonals of the quadrilateral, the 2 diagonals. So after calculating these 6 distances, we will be able to determine what type of quadrilateral we have. First, if all sides are equal and diagonals are equal to each other, then that type of quadrilateral will be known as a square. So if these 4 are the vertices of a square, that is, if ABCD is a square, then AB will be equals to BC, will be equals to CD, will be equals to AD. That is, AB, BC, CD and AD, all 4 sides, they will be equal. And we'll also have AC equals to BD. That is, the distance of the opposite vertices, which are known as diagonals, they'll also be equal. AC equals to BD. Next, if opposite sides are equal and diagonals are equal to each other, opposite sides are equal and diagonals are equal, then we call that quadrilateral as a rectangle. So if these 4 are the vertices of a rectangle, that is, if PQRS is a rectangle, then we will have PQ equals to RS, the opposite sides equal, and PS equals to QR, the other pair of opposite sides equal. So opposite sides will be equal. So as you can see, PQ equals to RS and PS equals to QR. And we'll also have the diagonals equal, that is, PR equals to QS. PR and QS, they'll also be equal. Next, if all sides are equal but diagonals are not equal to each other, then such quadrilaterals are called rhombus. Considering these to be the vertices of a rhombus, that is, if PQRS is a rhombus, then we'll have PQ equals to QR equals to RS equals to PS. That is, all 4 sides will be equal. PQ equals to QR equals to RS equals to PS. But PR will not be equals to QS. That is, the distance of the opposite vertices, the diagonals, will not be equal. PR not equals to QS. So a rhombus will have all sides equal but diagonals unequal. Moving on. If opposite sides are equal but diagonals are not equal to each other, then such quadrilaterals are known as parallelogram. Considering these to be the vertices of a parallelogram, that is, if ABCD is a parallelogram, then we will have AB equals to CD and BC equals to AD. That is, the opposite sides are equal. AB and CD, they are equal. And BC and AD, they are also equal. That is, the opposite sides are equal. But AC will not be equals to BD. That is, the diagonals will not be equal. AC not equals to BD. So if opposite sides are equal but diagonals are not equal, then we will call that quadrilateral as a parallelogram. So in a nutshell, we can say that if all sides are equal plus the diagonals are also equal, then the quadrilateral is a square. If opposite sides are equal plus the diagonals are equal, then the quadrilateral is a rectangle. If all sides are equal but diagonals are not equal, then it's a rhombus. And if opposite sides are equal but the diagonals are not equal, then it's a parallelogram. Now let's do some questions on quadrilaterals. The first question is, in a classroom, 4 friends are seated at the points A, B, C and D, as you can see it in the figure. 2 girls, Champa and Chameli, walk into the class, and after observing for a few minutes, Champa is asking Chameli, "Don't you think ABCD is a square?" However, Chameli disagrees. Now using distance formula, we need to find out which of them is correct. We need to name the type of quadrilateral formed, if it's forming any quadrilateral, and we need to give reasons for the answer. The coordinates of the 4 students are not given to us directly. However, the classroom resembles a Cartesian coordinate system, where the columns are horizontally aligned, representing the x-axis, and the rows are vertically aligned, representing the y-axis. So we can find the coordinates of the students using this. A's horizontal position is at 3, that is x coordinate is 3, and vertical position is at 4, that is y coordinate is 4. So coordinate of A is 3, 4. X coordinate first, followed by y coordinate. Similarly, B's position in the column is at 6, that is x is 6, and the vertical position in the rows is at 7, that is y is 7. So the coordinate of B is 6, 7. Moving on to C, the horizontal position is at 9, x is 9, and the vertical position is at 4, y is 4. So coordinate of C is 9, 4, x followed by y. Finally, D's horizontal position is at 6 and vertical position is at 1. So the coordinate of D is 6, 1. So we have found out the coordinates of all 4 students. Now, in order to determine what type of quadrilateral it is, we have already seen that we need to find 6 distances. Firstly, of the 4 sides, AB, BC, CD and AD, and then of the 2 diagonals, AC and BD. So let's start. So these are our coordinates: A 3, 4, B 6, 7, C 9, 4 and D 6, 1. So now we will use distance formula. D equals root over x2 minus x1 whole square plus y2 minus y1 whole square. So let's start with A and B, 3, 4 and 6, 7. Second minus first. So B's coordinate will subtract A. AB equals to root over 6 minus 3 whole square plus 7 minus 4 whole square. So 6 minus 3 will give us 3, that is 3 square, plus 7 minus 4 will also give us 3 square. 3 3s are 9, 3 3s are 9. So root over 18. 9 plus 9 will give us root over 18. 18 can be expressed as 3 3s are 9, 9 2s are 18. Since 3 is in a pair, we can take that out. So the distance of AB will be 3 under root 2 units. Now on to the next side, BC. B is 6, 7 and C is 9, 4. So BC will equal to under root 9 minus 6 whole square plus 4 minus 7 whole square. So 9 minus 6 will give us 3 square, plus minus minus, 7 being the bigger number, minus sign will carry on, minus 3 whole square. 3 3s are 9, minus into minus plus, 3 3s are 9. So under root 18. That is 3 into 3, 9, 9 into 2, 18. So we can write BC equals to 3 root 2 units. So this is our measure of BC. Now the next side, CD. C is 9, 4 and D is 6, 1. So the coordinates of D will subtract the coordinates of C. So CD equals under root 6 minus 9 whole square plus 1 minus 4 whole square. Plus minus minus, 9 is the bigger number, so minus sign will carry on. 9 minus 6 will give us 3, minus 3 whole square. Plus, again 4 is the bigger number, so minus sign will carry on. 4 minus 1 will be 3, so minus 3 whole square again. Minus into minus will give us plus. 3 3s are 9, again 3 3s are 9. So under root 18 again. So let's express again in the form of 3 into 3 into 2. So the measure of CD is also equals to 3 root 2 units. Now the last side, AD. A is 3, 4 and D is 6, 1. So AD equals under root 6 minus 3 whole square plus 1 minus 4 whole square. 6 minus 3 is 3 square, plus minus minus. The bigger number is 4, so minus sign will carry on, minus 3 whole square. 3 3s are 9, minus into minus plus, 3 3s are 9. 9 plus 9 will give us root over 18. 3 3s are 9, 9 2s are 18. So AD is also 3 root 2 units. So as we can see, all four sides are equal. So now we have at least come to know that ABCD is either a square or a rhombus. So out of the two, it's definitely one. So in order to distinguish between the square and the rhombus, we need to now find the length of the diagonals. First, AC. The coordinate of A is 3, 4 and C is 9, 4. So AC equals under root 9 minus 3 whole square plus 4 minus 4 whole square. So 9 minus 3 will give us 6, that is 6 square, plus 4 minus 4 will be 0, that is 0 square. So 6 square is 6 6 is 36, 0 square will be 0. So 36 now can be expressed as 6 into 6. So the length of AC is 6 units. The other diagonal now, BD. B is 6, 7 and D is 6, 1. So BD equals 6 minus 6 whole square plus 1 minus 7 whole square. 6 minus 6, that is 0, so 0 square, plus 1 minus 7, 7 being the bigger number, minus sign, 7 minus 1 will be 6. So minus 6, that is minus 6 square. 0 square will be 0, minus 6 square, minus into minus plus, 6 6 will give us 36. So now root over 36 again can be expressed as 6 into 6. So BD is also 6 units. So we got AB equals to BC equals to CD equals to AD, all sides equal, and AC equals to BD, that is the diagonals are also equal. So hence ABCD forms a square, as this condition satisfies for a square. All sides equal plus diagonals also equal. So Champa was saying it's a square, so Champa is correct. So we are done with the question. Sometimes as an additional part, you may also be asked to find the area of the quadrilateral you have got, especially in the case you have got a square, rectangle or a rhombus. So area of square is side into side, and area of ABCD will be 3 under root 2 into 3 under root 2, as the distance of the side was 3 under root 2. The numbers which are outside square root, let's put them together, 3 into 3, and the numbers which are inside square root, let's keep them together, under root 2 into 2. 3 3s are 9. Under root we have a pair of 2, that means we can take out 1 2 out. So 9 2s is 18, 18 square units. So area of ABCD is 18 square units. This was not asked in the question, but we are doing it as an additional part, as sometimes you may be asked to find the area as well. Let us do one more question, and the question is asking us to identify the type of quadrilateral formed by the vertices -5, -3, 1, -11, 7, -6 and 1, 2. We also need to justify our answer. Since the coordinates, they do not have any predefined notation, we can note them by any letter that we want. So we have used P, Q, R and S. P -5, -3, Q 1, -11, R 7, -6 and S 1, 2. Let us have a rough diagram as well. I suggest whenever the diagrams are not given, just draw a rough diagram, as it can give you an indication of which way to go or which are the sides and which are the diagonals that you need to find out. So Now we have to use the distance formula. D is under root x2 minus x1 whole square plus y2 minus y1 whole square. Let's start with the first side, PQ. P is minus 5 comma minus 3 and Q is 1 comma minus 11. So Q's coordinates will subtract P's coordinates. PQ equals 1 minus minus 5 whole square plus minus 11 minus minus 3 whole square. So 1 minus minus plus, so the sign has changed, 1 plus 5 whole square plus minus 11 minus minus, again the sign has changed, plus 3 whole square. 1 plus 5 will give us 6 square, plus minus minus, 11 being the bigger number, so minus sign will carry on. 11 minus 3, 8, minus 8 whole square. 6 6 36 plus minus into minus plus, 8 8 64. So 36 plus 64 root over 100, which can be expressed as 10 into 10. So we can take 110 out. So the distance or the length of PQ will be 10 units. Next side now. The coordinates are Q 1 comma minus 11 and R 7 comma minus 6. So distance of QR equals 7 minus 1 whole square plus minus 6 minus minus 11 whole square. The coordinates of R subtracting coordinates of Q. QR equals under root 7 minus 1, 6 square plus minus 6 minus minus plus 11 whole square. 6 square, then 11 minus 6, 11 is the bigger number, so plus sign, 11 minus 6 will give us 5, 5 square. 6 6 are 36, 5 5s are 25. So the distance of QR is equals to root over 61 units. Now the next side, RS, the coordinate of R is 7 comma minus 6 and S is 1 comma 2. So RS equals to under root 1 minus 7 whole square plus 2 minus minus 6 whole square. 7 being the bigger number, minus sign will carry on. 7 minus 1 will be 6 minus 6 whole square plus 2 minus minus plus 6. So 2 plus 6 whole square. Minus 6 whole square plus 2 plus 6 will give us 8. 8 whole square. Minus into minus plus, 6 6 are 36 plus 8 8 are 64. 36 plus 64 will give us under root 100, which can be expressed as under root 10 into 10. So the distance of RS equals to 10 units. Now the last side, PS. The coordinate of P is minus 5 comma minus 3 and S is 1 comma 2. So PS equals to under root 1 minus minus 5 whole square plus 2 minus minus 3 whole square. 1 minus minus plus, so the sign will change. 1 plus 5 whole square plus 2 minus minus, again the sign will change, plus 3, that is 2 plus 3 whole square. 1 plus 5, 6 whole square plus 2 plus 3, 5 whole square. 6 6 are 36, 5 5s are 25. So the distance of PS is under root 61 units. So we have come to know that the opposite sides of this quadrilateral are equal. So it can either be a rectangle or a parallelogram. Now we need to find the length of the diagonals in order to decide whether it's a parallelogram or a rectangle. First, the length of the diagonal PR. Coordinate of P is minus 5 comma minus 3 and coordinate of R is 7 comma minus 6. Distance PR equals to under root 7 minus minus 5 whole square plus minus 6 minus minus 3 whole square. 7 minus minus, the sign will change, plus, so 7 plus 5 whole square plus minus 6 minus minus, the sign will change again, minus 6 plus 3 whole square. 7 plus 5 whole square, 7 plus 5 will give us 12, so 12 whole square plus minus 6 plus 3 whole square, 6 being the bigger number, minus sign will carry on. 6 minus 3 will be 3, that is minus 3 whole square. 12 12s are 144 plus minus into minus, sign will change, plus 3 3s are 9. So we have got under root 144 plus 9. That is the distance of PR equals to under root 153 units. Now let's find the distance of the second diagonal. QS. The coordinate of Q is 1, minus 11 and S is 1, 2. So QS equals to under root 1 minus 1 whole square plus 2 minus 11 whole square. 1 minus 1 will be 0, so 0 square plus 2 minus plus, sign will change, plus 11 square. 0 square will be 0, so we can leave that. 2 plus 11 will be 13, so 13 square will get, which can be expressed as 13 into 13. So the distance of QS will be 13 units. So as we can see, the diagonals, they are not equal. So let's conclude. We got PQ equals to RS and QR equals to PS. That is, the opposite sides equal. And PR not equals to QS. That is, diagonals are not equal. So this condition satisfies that the quadrilateral is a parallelogram. Hence, the given vertices forms a parallelogram. So we are done with this question as well. Now these are assignments for you which are similar to the questions which we have discussed in the video. In the next part, we will be doing some more questions of the same type and we will be trying to find other quadrilaterals as well. Thank you and have a nice day.